Alright, we're rolling. I think this is video 111, 112 or something like that. We're getting up there. And didn't get a chance to do testing today. Tomorrow maybe the weather's going to be more sunny. Hopefully my head's not being cut off here. And my call goes out to everyone out there who wants to build an inexpensive waste oil heater that works. And I only basically know, what I've been doing with the Joe pipe. Like, as you know, the Joe pipe operates on extreme temperatures. So why not take those extreme temperatures to make a fire pot. And this fire pot here is just a round piece of metal that's been welded on the back, so you can take a section of pipe, maybe 8-inch section of pipe, weld the back, and the whole thing fits into this housing. So I like to make everything simple and to where it can be changed out if it has to be repaired. And this fire pot here is ceramic. Remember, I got it's something like a refractory pour that you can get. It's fairly expensive, but you would take this and set it upright and have your cone ready to stick in, so you can actually get your shape. So you pour your refractory mix into the fire pot. You just suspend your cone there and leave it sit for a couple of days, and you have to leave it dry for about a week, maybe longer. And so this actually be better than the fire brick, because you have something that's going to handle the heat, up to about 3,000 degrees anyway. And the more heat that you put on this, the harder it's going to get. And one of the big problems with waste oil heaters, from what I've heard, is your pan. But in this instance, you don't have a pan where you could build up where all the garbage comes out of the waste oil, your metals, things like that. Well, these kind of heats, I'm pretty sure that your metals are not going to cluster, and they're not going to gather. And if they do, well, they just clink down here, right? And so maybe this horizontal system is going to be a better approach than a vertical system. And for those who have hands-on expertise in the refractory business and who have made waste oil heaters, I know there's this one brother down in Oz, down in Australia. He's been doing a lot of his own work into taking the Joe pipe to try to use it to burn oil. And one of the problems that he found out is that you can't, just using a fan, it doesn't give you the heats to where it's going to run on waste oil itself. Like when you turn off the gas or the propane, while the fire dies out. And one way to compensate for that, in the back here on your later version JP models, you have a steamer, and you could actually inject, like the pipe gets hot enough where it's going to heat a steamer up to 400 or 500 degrees anyway, where you could drop feed water into the steamer and it'd actually give you your hydrogen. And I've already seen the hydrogen go from the hydrogen state into a yellow-white flame, and because the heats are intense. So this would work, and maybe the propane would just be on pilot, more or less, and or the steam would, because the heat's going to back up into here, and this is going to be hot, and so the water might be at high enough temperature and all that, where the steam's going to convert directly into hydrogen. So you're going to get extreme temperatures here. You're talking white hot heat. Well, you're going beyond the orange or the red. You're going into white hot here. And so you want to design your metal out of 1/2 inch. 3/8 metal might be on the light side. As far as your fire pot, you want to use 1/2 inch metal, and to where you can just insert it, and to where you have, when you have to change it out, you can change it out to repair it, fix it up, or whatever. And so the Joe pipe would actually be a JP2 model, and I've added slash waste oil burner. So when you see JP2, you know that it's the Joe pipe has a secondary pipe over here, which allows you to blow in your air and your fuel mix to be preheated, superheated, and then go into the center of your Joe pipe. And you could also, when you get it going, you might be able to just spray water in here, and the water will convert to steam. And so you could have an external steamer that would generate steam into the WOB. And something needs to be done. There's lots of waste oil out there, you know, engine oil, tranny oil, things like that. The kind of temperatures that are in here are going to bring it beyond the vaporization point of the fuel. And just like in water, if you get it hot enough, it turns into steam, right? But if you get steam hot enough, it goes from the wet steam into a dry steam, and you're actually seeing the phase change from a water state to a vapor state. And once water is in the dry state, where it's 100% gas, no water, no moisture, then it doesn't take much to superheat it to maybe a few thousand degrees, where it's going to convert into hydrogen. And there's no reason why the same can't be true for your oil vapor, that your temperatures are going to be such that your vapor is going to flash, you know, from being a vapor into a dry state, you know, like superheated steam. And at that point, your fuel vapor or your oil vapor is going to release much more energy, and we're talking in the thousands of degrees. If you know, maybe 3,000–4,000 degrees, and if it does become plasma, you're talking hotter. And so if you get fuel up to where it's fully atomized into a dry state, that where it turns into hydrogen, and the hydrogen is going to burn the carbon that's in the fuel. So you could have a full, complete burn, near zero emissions, right? So that's what I'm hoping to achieve here. You out there who are experts in this field, I'd like to hear from you to see what you would think on using this kind of configuration, where you're heating up this cone, this inverted cone, and the hot oil is superheated as it comes in here. So the time the oil gets to here, it's way past the boiling point. When it leaves here, it's going to convert into a high vapor state to be combusted. And the cone should generate a fairly intense vortex motion, so that the fire is actually spun out from the periphery. And so you're going to develop almost like a kinetic energy wheel fire here. So the fire is going to go, the heat of the fire is going to go from the center out. So this whole, if this was the actual size of the heat box, and my design for the heat box is hexagonal, and just easier as far as saving on your metal and all that, and it's strong, and this heat box will probably get up to 800–900 degrees. So this whole thing, you know, becomes a heat exchanger, and you got your pipes going through here that allows air to be blown through. But this would be the first of three bodies. This would be your inner body, and you'd have another body wrapped around this, and that would capture your exhaust. So you got your heat plenum, you would have an exhaust plenum wrapped around this, and around that you would have like an air plenum, and to take your hot air to exchange the heat from here into your air. So on this side, you're probably going to want like a large fan, and this would become a very efficient way to convert waste oil into heat, where you could have a stand-up model, and you could heat up 1,000